Hello friends, today our topic is the Newton's forward interpolation using C++ or using C program. If you want to know how to evaluate using the Newton's forward interpolation mathematically, you can check the video link from the description box. Now, for the Newton's forward interpolation using C program or C++, at first we should discuss about the algorithm on the Newton's forward interpolation, then the flowchart, then the program would be executed. So, what is the algorithm for the Newton's forward interpolation? Let's check. So, we are proceeding with the Newton's forward interpolation. And we are here with the algorithm. As you know, the Newton's forward interpolation is for the equal intervals. Equal intervals. So, what is the algorithm at first? At first, read x0, comma h, comma n. Now, these variables, x0 is the initial value of x and h is the interval. So, when we are inserting the x0 or giving the value of x0 at first, so from the equal interval we can find out the values of x1, x2, x3, x4 and so on, because we know x1 is equal to x0 plus h or x2 is equal to x0 plus 2h in that way. And what is n? N is the number of data parts. That means how many data we should insert for the calculation, and that should be -1 because we are giving the value of x0 or the initial value of x at first. That's why we are calculating the n for the n minus 1 in that way. Second step, read yi. That means where I is equal to from 0 to n, 0, 1, 2 up to n. So for the values of x0 we are finding the y0, for the values of x1 we are finding the value of y1 in that way. Next one, we should proceed with the step 3. Here we are reading or wanting the input from the user, the value of small l, where l is the number of required interpolated values of y. Interpolated values of y. That means for how many values of x we want to find out the value of y. Step 4. Here read xi. That means for which values we want to find out the value of y. And obviously I is equal to 0, 1, 2 up to the l minus 1. So we can write it as the values for x for which y are required. Then the step 5. For j is equal to 0 to n, do till 7. We have not described the step 7 yet now, but we will discuss it now. So for j is equal to 0 to n, do till 7. Step 6, just here, write down the f0, comma, j, and we are assigning the value of yi to that particular f0, comma, j. So that means at that moment we are assigning the value of f. So next 7, next j. That is our loop. So that's why till 7 has been written. So for j is equal to n, next 7 the loop is executing and we are assigning the value of yi to the f0j. That is looking like that one, 0j. Next step 8. For I is equal to 1 to n, do till 12. So that is also for a loop. Next step, for the execution of for. Another for would be in between the for I. So for here j is equal to from 0 to n minus I, do till 11. So that is for the loop of j. Step 10, here we are assigning f of I comma j is equal to f of I minus 1 comma j plus 1 minus f of I minus 1 comma j. That means that is also we are assigning like that, f of I minus 1 to j plus 1 minus f of I minus 1 of j to f of I j. So step 11 is the end of that particular for j loop. So here we are writing next j, and step 12 is for the next I, that is for the loop of for I is equal to 1. So next step 13. Here for k is equal to 0 to L minus 1, do till 21. Here what happens? We are assigning the value of xk minus x0 by h into u, and that is our step 14. So what is our step 15? Another assignment. We are assigning the value of y0 to the yk, capital YK. And for the step 16, we are assigning or initializing the value of p as 1. So step 17, here for I is equal to 1 to n, do till 20. That is for the loop execution. Step 18, another assignment. Here we are assigning the value of p u minus I plus 1 divided by I to p, and the 19, that one we are assigning the value of yk plus p of fi comma 0 to capital YK. So step 20, as you know, the end or for the loop. So here we are writing next of I, and for the step 21, that must be write xk comma yk, and that must be there also another one. So after next I there would be another next k. So what is the last statement, that is 22, that is our end of the complete algorithm. So that is the algorithm how we can proceed with the Newton's forward interpolation of equal intervals. So next check what is the flowchart of the Newton's forward interpolation, and we are now proceeding to the flowchart. So the first one must be the start, as you know. So that is our start. Next one, read. So read n, then the initial value, then step size values of y, values of x, for which value of y are required. Now the next step is for j is equal to 0 to n. Then we are assigning as like the algorithm, that is f of 0 comma j must be with yj. Next step, we are ending the loop. So here end loop of j. So next step, we are proceeding with the I. So for I is equal to 1 to n, another for loop is here as like the algorithm, and that one is the for j is equal to 0 to n minus I. So the next step would be the assignment, and here we are assigning like f of I j, that should be f of I minus 1 and then j plus 1 minus f of I minus 1 with j. So that is our assignment for the j loop. Practically, that is also an inner loop of the I. So here end of the loop for j, end loop of j. Then another end of the loop of I. The next step is practically for the k loop. So here we are proceeding with for k is equal to 0 to L minus 1. Now some assignments would be there, and for that we are assigning capital of xk minus x0 divided by h is equal to small u. Capital of yk should be small y0, and p is assigned as the initial value with 1. And next step would be for I is equal to 1 to n. Here assignments like p is equal to p star u minus I plus 1 by I, and capital of yk should be small of yk plus p into f of I comma 0. So that is for the assignments under I loop. And after that the step is for the print, and here we have to print the xk comma yk, that is the output. So here we are ending the end of loop k. Practically in the algorithm there was an error. Here we have said the next k would be here. No, the next step would be after the writing or printing of the xk and yk. So here the next k would be, then the end of the program or the algorithm is. So here end of loop k and then end of loop I. So here after that we are just stop the flowchart. So let's check what happens with the real C program. Here that one is the forward interpolation formula using C, or you may say also using C++. So already as said, we have taken the integer value of I, N, J, K and L. Those are the variables. Then the float values had been taken x0, y20, f10 and 10, x10, y10 and hup. Then we have called the CLR SCR function. Practically that does not happen now. So the syntax would be system and in parenthesis within double quote CLS. So as described earlier, next would be from the user. Enter the value of n. That means number of data pairs minus 1. Practically what we want? We want, suppose we have value given for respective x and y. Suppose x, y. So the values for x is equal to 40. That one has been given y as 184. For value of 50, as those are the equal intervals, so always there are equal intervals of 10. So it is 10 like 70, then another 10, so that is 80. Suppose another 10, that is 90. So the values of respective y has been given, so that is 204, suppose 226, suppose 250, 276 and suppose 304. So that is our x0, x1, x2, x3, x4 and x5. So respective y0, y1, y2, y3, y4 and y5 are given. So how many values we want? How many data has been given? That is the paired data. So here the number of pair data has been given is equal to 6. 1, 2, 3, 4, 5, 6. So let's check the program once again. Here, the number of value of n, that should be, if we want to input the 6 data pair, that must be 5, because number of data pairs minus 1 here. So scan a %d, comma ampersand n. Enter the initial value of x. Already the x0, that means that has been given as the equal interval. So we can find out the x1, x2, x3, x4, x5 in that way. So we are giving the initial value of x using ampersand x0. So x0 is the initial value of x. Enter the step size, that means the interval value, such that for the previous problem it was 10. So here we are giving that interval value using the variable h. Enter the values of y. Now we have to give the values of y respectively. That means if we have 40, then we have to give the values 184, 204, 226, 250, 276 and 304. So that's why we need a loop, and we are using the for loop, and that's why that is I is equal to 0 to I less than n plus 1, and we are giving I plus plus. So we are just inputting the value of y using y I, that particular array. Then enter the required number of interpolated values of y. Practically here we may find several values of y for the several values of x. Like problem, if we want to find out the value of x is equal to 100, 110, 120, so there should be the 3 values for which we want to find out the value of y. So here also we wanting the enter the required number of interpolated values of y. It may be 1, it may be more than 1. So we are giving the value of that particular interpolated values of y in the form of variable L. Now enter the %d values of x for which values y are required. As we are giving L number of values, we want L number of values. So k must be from 0 to less than L. And we are giving this value using the array of x and array of xk. Then j is equal to 0. Now the calculation begins for the interpolation. So here first one we are assigning the value of yj into the form of f0j. Then I is equal to 1 to I less than n plus 1, and then j is equal to 0 to j less than n plus 1 minus I. We are assigning the value of fi minus 1 j plus 1 minus fi minus 1 j up into fij. So after assigning, we are getting the value. So we are just now giving the value of y, and here we are finding the first one u. So from k is equal to 0 to a, we are assigning xk minus x0 by h is equal to u. We are assigning the value of that particular into u. Then yk should be by 0. Then we are initializing the value of p as 1. Then for I is equal to 1 to less than n plus 1, we are putting the value of p as p is equal to p into u minus I plus 1 by I. And yk, capital Yk is equal to capital Yk plus p into f of I 0. Then just we are giving the values of x and respective y. Let's check what are the result we get or output. So execute the program. Enter the value of n. Suppose here we are giving the value of n as 7. So enter the initial value of x. We are giving it as 0. Enter the step size in h. So we are giving 1. So that means the values of x would be 0, 1, 2, 3, 4 in that way. Enter the values of y at that moment. So we are giving